Hey everybody, in this video toolkit we are going to talk about circles in the coordinate plane. Okay, so let's start with this circle that's right here. We've got the R is our radius. We've got some point on anywhere on the circle. I'm just showing it here, but it could be anywhere around the circle, and that's X and Y. And this one is centered on the origin. So that means we've got also a center point of 0, 0. So now if we wanted to come up with an equation for this thing, we would have R, just using the distance formula, R is equal to the square root of x minus 0 squared plus y minus 0 squared. And of course we could simplify that, get rid of those zeros, and we could just say R is equal to x squared plus y squared. If I squared both sides of this equation to get rid of that square root sign, maybe I don't like looking at that square root sign, I would get R squared equals x squared plus y squared. So, as I mentioned, these two equations with the square root sign, that comes from the distance formula that we've learned about in previous lessons. And if we look at this r squared bit, if we go up to our circle and we drop a line down and make a right angle, we have a right angle triangle, and this distance here is x, because that's how far we've over on the x-axis we've moved to get to the point xy. We've moved that far to the right. And we've moved this far up, so that's our side x and our side y. And so if we have x squared plus y squared being the legs of a right triangle, then we know that the radius is the hypotenuse, and this formula then is essentially the same thing as the Pythagorean theorem. So that's how we can find the formula for a circle centered on the origin. Now, not all circles are going to be centered on the origin. Maybe we've got one centered off the origin, and we'll just say it has a center at HK, right? So we still have this radius here. We know we're not centered on the origin, and if we just replace from our first equation, and instead of having the minus zeros, where we're subtracting the center of our circle, we can come up with a formula for the circle being R equals the square root of x minus h squared plus y minus k squared. So notice that the x and y haven't changed, but the h and the k, or the center, has changed. So we're just, that second part of each of those brackets is the center of the circle. Now, if we squared both sides, again, we could have r squared equals x minus h squared plus y minus k squared. That's just squaring both sides. And just like before, this one comes from the distance formula. This one comes from the Pythagorean theorem. So it's just another way of writing each of these things. So one other thing to note about this second not centered on the origin circle is that we can say that a circle is tangent to a line or a point, if we want to say a point, if it touches one spot on the outside of the circle. So that means that the line or the point is tangent if it only touches one spot. So here, where this circle is touching the y-axis, we can say that the circle is tangent to the y-axis. Or we could say the line x equals 0. That's another way to say the y-axis. X equals 0, because no matter what value we pick for y, we will always have a value of x being 0. So that's why that equation is x equals 0, or the y-axis is x equals 0. So if we look down here, though, the x-axis is not tangent, or the circle is not tangent to the x-axis, or the line y equals 0, because it cuts through the circle. It touches it at more than one point, more than one spot on the outside of the circle. So this is not tangent. So tangent means it's just kind of grazing by the circle, okay? So that's kind of separating or defining what a tangent line is. So let's look at just a real quick example to see kind of how these things work a little bit. Not real in depth, but just kind of plugging some numbers in. So let's say we want to write the equation for the circle that looks like this. So we've got two coordinates. It's not plotted on the plane, but we do have two coordinates. So we do know that this is our radius. So we know that we can do our radius. We've got a center of 2, 1, and at some other point, 10, 1. So we can use the radius formula, and we could say 10 minus 2 squared plus 1 minus 1 squared. So just taking x2 minus x1, y2 minus y1, squaring each of those, adding them, square root. So we get the square root of 8 squared plus 0 squared, so that's going to be the square root of 64. So our radius is 8. Now, if you were paying attention, you may have noticed that these two things had the same y value. So that means it's on a horizontal line. So you could also have said, well, the radius is just 10 minus 2, and that would also give you a value of 8. So now we have both the radius and we have the center, so we can put together our formula for the circle, or the equation for the circle, and that's 8 equals square root of x minus 2 squared plus y minus 1 squared. Now notice that this equation has an x and a y in it. Almost all your equations, when you write equations, will have an x and a y in it. So if you're asked to find an equation, make sure that you have that x value in there and the y value in there. The only exceptions tend to be horizontal and vertical lines. Pretty much anything else you're going to come across when you're finding an equation to a line is going to have some version of x and some version of y. Okay, so we could write it this way, or we could of course square both sides and get 64 is equal to x minus 2 squared plus y minus 2 squared. So the thing to really keep in mind is that you always kind of have to keep track of that square root, and what if your radius, if you've got the square root on the parentheses side, then you know your radius is as it is. If you don't have that big square root sign, then you know that your radius is squared. So if you want to find out what that radius is, you're going to have to take the square root of that. So hopefully that helps with this toolkit, and I'll talk to you in the next one.